Components of AB will be given by position vector B minus position vector A, which is -1, -1, 12, minus position vector A, -5, 3, 4. -1 minus -5 is +4. -1 minus 3 is -4. 12 minus 4 is 8. To show that A, B and C collinear, we first of all work out BC, which is C minus B. Position vector C is 1, -3, 16, minus position vector B, which is -1, -1, 12. Taking them away, 1 minus -1 is 2, -3 minus -1 is -2, and 16 minus 12 is 4. We notice that this vector, A to B, is 2 times the vector B to C. So we can write down that AB is equal to 2 BC. When we can do this with 2 vectors, or 2 directed line segments, we can then conclude that AB must be parallel to BC. Also, since B has been used in common in both calculations, B is a common point. And because B is a common point to both calculations, not only is AB parallel to BC, this tells us that AB and C must in fact be all in a straight line. AB and C are collinear. We can work out the position vector of G if we use this diagram. A is the point 4, 2, -3, and F is the point 8, -6, 9. We want to find the point G which divides this line in the ratio 3 to 1. Position vector of G will be given by 3 times F, that's 3 times position vector F, plus 1 times E, which is plus E, and we divide that by the sum 3 plus 1. Now, 3 times F is 3 times 8, -6, 9. And that is 24, -18, 27. E, position vector E, is 4, 2, -3. Now, 3F plus E is equal to 24 minus 18, 27, plus 4, 2, -3. And this gives 28, -16, 24. We've still got to divide this by 4, and that will give us that G, this position vector, 7, -4, 6. And so the coordinates of the point G will be 7, -4, 6. Now, first of all, PQ dot PR is going to be -2 times 5, which is -10, plus 1 times 0, which is plus 0, and 2 times 12 plus 24. So that gives us minus 10 plus 24, which is 14. So PQ dot PR is 14. To find the size of the angle QPR, we call it theta, then cos theta is equal to PQ dot PR divided by the magnitude of PQ times the magnitude of PR. We already know PQ dot PR. Still to find the length or the magnitude of PQ and the length or magnitude of PR. Now, the magnitude of PQ is the square root of the sum of the squares of the components. So it's minus 2 squared, which is 4, plus 1 squared, 1 plus 2 squared, which is 4. So this is the square root of 9, which is 3. The magnitude of PR is the square root of 5 squared, which is 25, plus 0 squared, which is just 0, plus 12 squared, which is 144. So this is the square root of 169, which is 13. Back to our formula. So cos theta, on the top we've got PQ dot PR, which is 14, over the length or magnitude of PQ, which is 3, times the length or magnitude of PR, which is 13. So this gives us that cos theta is 14 over 39. So to find theta, we do cos inverse 14 divided by 39, which gives us 69 degrees. So angle QPR is equal to 69 degrees. Y is equal to 1/4 sine x. The y by dx will be 1/4 cos x. Differentiate 8 cos x, we get minus 8 sine x. F of x is 4x plus 1 to the power 7. To find f dash x, we use the chain rule. So first of all, we've got 7 times the brackets to the power 6 times the bracket differentiated. The differentiating the bracket just gives us 4. Put this bracket back in, 4x plus 1. Now we can multiply the 4 times the 7 to give us 28. So it's 28 bracket 4x plus 1 to the power 6. Number 6, the integral of 5 cos x is 5 sin x plus c. Integrating 2/3 sin x, integrating sin we get negative cos, so to integrate 2/3 sin x we'll get negative 2/3 cos x plus c. Evaluating the integral x minus 1 to the power 3. The integral of x minus 1 to the power 3 is x minus 1 to the power 3 plus 1, which is 4. We then divide this by that new power of 4 times the number in front of the x, which in this case is just 1. So it's just a 4 on the bottom. This is to be evaluated between x equals 0 and x equals 3. We now form two curved brackets. Into the first bracket we're going to replace x by 3, second bracket the x by 0. So this gives us 3 minus 1, which is 2 to the power 4 over 4. Second bracket, 0 minus 1, which is minus 1 to the power 4 over 4. 2 to the power 4 is 16, so it's 16 over 4. Minus 1 to an even power gives plus 1, got a minus outside the brackets, so this will be minus 1/4. 16 quarters minus 1/4 is 15 quarters, which we could also write as 3 3/4. First law of logs tells us, since we've got the same base here, log to the base a of 15 plus log to the base a of 3, we can multiply and combine it into one log. So this is log to the base a of 15 times 3, which is log to the base a of 45. 2 log to the base 4 of 6 minus log to the base 4 of 9. First of all, the third law of logs tells us we can take this 2 and bring it into the log as a power. So this is log to the base 4 of 6 to the power 2 minus log to the base 4 of 9. The second law of logs tells us that we can now combine these by dividing 6 squared by 9 inside the log. Log to the base 4, 6 squared is 36, divided by 9. Now 36 divided by 9 is 4. Log to the base 4 of 4 is 1. Solve e to the x equals 6.5. And solve this by taking logs of each side. Now since this is e to the x, we take log to the base e of each side. Log to the base e of e to the x equals log to the base e of 6.5. Using the third law of logs, this x can be put before the log. So this gives us that x times log to the base e of e is equal to log to the base e of 6.5. The log to the base e of e is 1, so this just leaves us with x, so it's x times 1 is x is equal to log to the base e of 6.5. Log to the base e in the calculator is called ln, so we just press ln of 6.5, which gives us 1.872 to 3 decimal places. Finally, question 10. This is a log equation. We can always solve a log equation by changing it into exponential form. The answer to the log is the power. The base of the log is 3, so we can say that 3 to the power of 2 equals x plus 5. Now 3 to the power of 2 is 9, equals x plus 5. So this gives us that x is equal to 4. To begin with, we let 4 cos x plus 5 sin x be equal to k cos x minus a. Expanding k cos x minus a gives us k cos x cos a plus k sin x sin a. Now comparing the left hand side and the right hand side, you see that 4 is multiplying cos x on the left hand side, k cos a is multiplying cos x, so k cos a must be the same as 4. On the left hand side, 5 is multiplying sin x, and on the right hand side, k sin a is multiplying sin x. So k sin a degrees must be the same as 5. To solve this, we square and add the two equations. So we get k squared sin squared a plus k squared cos squared a is equal to 5 squared plus 4 squared. K squared sine squared A plus K squared cos squared A, taking a K squared out of a set of brackets, of sine squared plus cos squared in the brackets, but this is just 1. So the left hand side is just K squared times 1, which is K squared. The right hand side we've got 25 plus 16, which is 41. So K is the square root of 41. To find A, we divide the two equations. Sine over cos is tan. So K sine A over K cos A gives us that tan A is equal to 5 over 4. Looking at these three equations, the sine is positive, first and second quadrants. Cos is positive in the first and the fourth quadrants. Tan is also positive in the first and the third. The angle we are looking for will be a first quadrant acute angle. So to find A will just be the acute angle given by tan inverse of 5 divided by 4. Tan inverse of 5 divided by 4 gives us that A degrees is equal to 51.3 degrees. So now writing 4 cos x plus 5 sin x in the form k cos x minus A, we can write root 41 times cos x minus 51.3 in brackets.